Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
This is question from May-June 2016, paper 13, question 4. So the relative atomic mass of copper is given, which is 63.5. The question wants us to get a correct mass spectrometer that would lead to this value. So we cannot pick A as the answer, even though here we have 63.5 with 100% of the percentage abundance. It's because M over E is actually mass number. So where mass number must be in the whole number. So it shouldn't be in decimal places. It's because mass number is actually the total number of proton plus neutron. So let's go to B. So what can we get? The relative atomic mass of copper. We should make use of this equation to get the average mass. So we should get the sum of the mass of isotopes multiply percentage abundance over the total percentage abundance. So normally the total percentage abundance will be 100. So let's try for B. So what we have here is that we have 17 times 62 plus 33 times 63 plus 50 times 65 over the total abundance where we have 17 plus 33 plus 50. So with this working, we'll get 63.83 as the answer, where it is not the same as what we have here, 63.5. So next, we'll go for C. So for C to go, we will have 74 times 63 plus 26 times 65 over the total percentage abundance. With this, we'll get 63.52 as the answer. So it matches to this 63.5. So the answer is C. Next question to go is actually from October-November 2003, question 1. So question wants us to find how many molecules of amino acid in this mole. So we could actually make use of this equation in getting the total number of particles, where we have here molecules of the amino acids, by getting the number of mole multiply Avogadro constant. So Avogadro constant, we can get it from data booklet first page, and it is 6.02 times 10 to the power of 23. So this figure here, where they give us with MR 200, actually we do not need this for the calculation. So question here is just to confuse us. So we can actually just get 3 times 10 to the power of negative 21, the mole of the amino acids, multiply Avogadro constant, which is 6.02 times 10 to the power of 23. With this working, we could get the number of molecules of amino acids with 1806. So the answer is C.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with one or two past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.